Hi everyone. Let's start with today's problem, Leetcode 3542, that is minimum operations to convert all elements to zero. Here an array nums is given that consists of non-negative integers. Our task is to apply some possibly zero operations on that array so that all elements become zero. Here we can select a subarray ij and set all occurrences of the minimum non-negative integer in that subarray to zero. We have to return the minimum number of operations to make all the elements in the array zero. Let's take a look at the few test cases to decide how we can move forward. Let's take a look at these test cases. Here, given a nums array consisting of four elements, that is 3, 1, 2, and 1. In this particular example, we can make both ones to zero at the same time, and for 3 and 2 will require two separate operations. So in total it will require three operations to make all the elements of this particular array to zero. Now when the for the fourth element, that is 1, we'll also need to keep track of the second element here. So one way to do that in data structure that we can use is stack. So I'll show you how we can solve that problem using a stack. Let's start iterating from the initial element to the last element of this particular array. Initially, the value of I is equal to 0 and nums_i is equal to 3. So what we'll need to do, as the current value of a stack is empty, we'll just put this value to the stack, and as this is a value and if we need to make this value to 0, we will need at least one operation. So therefore the result is 1 for this particular value from the nums array. Next, I is incremented by 1 and the current value of nums_i is equal to 1. So what we'll need to do, as we are only focusing on the minimum elements in the array, not the maximum element, so we'll check if the current value of the nums array is greater than or less than the top of the stack values. Here you can see that the current value of nums array is less than the top of the stack values. So what we'll need to do, we'll need to remove the stack values there, remove the values that is currently at the top of the stack, and put 1 here. As 1 is a new element and it will require at least one operations to make that element to 0. So therefore result is, we'll need to perform one more operation, so therefore result is incremented by 2, incremented to 2 here. Next, I value is increased by 1 and the current value of nums_i is equal to 2. So what we'll need to do, we'll compare the current value of nums array with the top of the stack values. Here, the current value of nums array is greater than the top stack values. So the previous minimum elements might be useful later. So therefore, we'll keep the values of the top of the stack and put 2 on the stack. So as 2 is a new values there, so we'll need one more operations to make that element to the 0. So therefore the result is also incremented by 1 here. Next, the current value of I is equal to 3 and nums_i is equal to 1. So what we'll need to do is, first we'll compare nums_i with the top of the stack values. Here 2 is greater than 1. So we are focusing on the minimum elements, not on the maximum elements. Therefore, we will delete 2 from the stack. Now, both the values of the nums_i and stack is the same. So as 1 is already there, we do not need to put anything on the stack. So, and we also do not need to perform any operations to make the elements to the zeros, as both ones can be converted to 0 at the same time. So therefore the result will remain the same and it will be 3. Let's take a look at another test cases. Here the test case is 3, 1, 2, 2, 1. So the first value of the nums array is 3. So currently the stack is empty. So we'll need to put that values to the stack. So we'll put 3 in the stack, and for that we'll need at least one operations to make that element to the 0. So therefore the result is 1. Next, I is incremented by 1 and the next value of the nums array is 1. So we'll compare that values with the top of the stack values, and the top of the stack values is greater than the current values of the nums array, and we are not focusing on the maximum element, rather we are focusing on the minimum element. So therefore we'll delete that element from the top of the stack and put 1 to the stack values. So 1 is a new values here, and therefore it will require one more operations to make that element to the 0. Next, I is incremented by 1, that is 2, and the current values of nums I is equal to 2. So the current values of the stack is less than the current values of the nums array, so that is 2. So that stack values might be useful later. So that's why we'll keep that values and put 2 on top of that. As 2 is a new value is here, so we'll need at least one operations to make that element to the 0. Next, I is incremented by 3. The current value of the nums array is equal to 2. So we'll compare nums I with the stack. So both values are the same. So do not need to perform any operations. So rather result will remain to 3. Next, I is again incremented by 1. So the current values of I is equal to 4 and nums I is equal to 1. So top of the stack values is greater than the nums I values. So therefore we'll first delete that values, and then again we'll compare current values, that is nums I, with the top of the stack values. So both values are the same. So both values can be converted to 0 at the same time. Therefore we'll do not need any other operations and result will remain the same. So that is 3. So for this test cases we get the result 3. Let's start writing the code. As this solution require using a stack, so let's first initialize the stack. Now let's iterate over all the elements of this particular array. So for num in nums, now we'll need to delete all the elements from the stack that is greater than the current value. So while stack and stack top is greater than num, stack dot pop. Next, when shall we put the elements to the stack? So if the values that are if either the stack is empty, or if the if the top of the stack values is less than the current values. So for that, if not a stack or stack top is less than num, then we'll put values to the stack, that is stack dot append num. And then we'll also need to increment our result values by 1. So result plus is equal to 1, and for that we'll also need to initialize the values to 0, and then we'll need to return the results. We'll need to do one more thing. So when the values of the stack when the values of the array is 0, we will not do anything. So to do that, so we'll put elements to the stack or increment the values of the results by 1 when the values is greater than 0. So if num is greater than 0 and this condition satisfies, then we'll increment our result by 1. So let's run this code, and it passes all the sample test cases, and let's submit the code and see if our solution is accepted or not. And as you can see, this solution is accepted, and the time complexity of this algorithm is order of n, and the space complexity is order of n also, as it requires using a stack.